Hello students, I am Dr. Saleha Jamal from Department of Geography, Aligarh Muslim University, Aligarh. Welcome to the today's class. So students, if you remember, we are in discussion with the how the different spatial analysis tool works with reference to the we were discussing with reference to the certain case studies. In previous class I have discussed about the how the buffer works in spatial analysis, and today's class we are going to discuss how interpolation works in spatial analysis with the help of certain case studies, so that to make you more clear about the, because we have discussed these like buffer, interpolation, overlaying bit by bit in the previous classes, and now we are going to discuss with some of the case studies to have clear understanding. So let us start with the today's class. This first I would like to talk about little bit basic concept when we are talking about how this interpolation works in how this interpolation works in spatial analysis. Before that, you must review what are the certain spatial analysis tools we talked about. So actually the spatial analysis tool encompasses a range of, I can say, the techniques, the softwares which is generally used to analyze the spatial data. Any type of relationship is existing in this, or any sort of patterns or trends is existing in the spatial data. For this purpose, certain spatial tools and techniques and softwares are generally used, and these tools play a very important role in different fields like in geography, urban planning, environmental science and public health, and various other disciplines, etc. Mainly it helps us to understand and manage the spatial data in order to understand various spatially distributed phenomena. It also helps to facilitate in informed and more smart decision making in various disciplines. So basically these spatial analysis tool play a very important place in our day-to-day life, and with that we can use it in n number of ways to make our life a bit easier. And I have explained some examples also how these tools are used in order to when we are going to book certain taxi on particular app, when we are going to book our meal, and many times we used to track when our meal will be arriving in order to find out the certain short routes for the delivery, in order to track even the train status. All these things our day-to-day routine life have the use of this spatial analysis tool. So let us discuss before having the case studies bit by some of the common spatial tools, so you may have a bit review of the previous classes. One of the very important spatial analysis tool is Geographic Information System, GIS. It holds a lot number of tools which helps to perform various operations and functions. If you remember, I talked about buffer, I talked about overlay, I talked about interpolation, network analysis, etc. So basically GIS software, it allows us to first acquire, that is the capture the spatial data, to store that spatial data, and then to analyze and visualize that spatial data. It provides a complete environment of capturing also, storing also, visualizing also, analyzing also. Complete environment this particular software gives. So it is a one of it provides the tools, we can say the querying tool, or even the mapping and the modeling tools through which we can find out the spatial relationships between different entities, features, etc. Not only this, it can integrate the spatial data which is acquired for distant sources. After the normalization of data, we can have the over analysis, we can have the spatial interpolation, etc. So a lot of functions can be performed from this particular analysis tool. The second most important analysis tool is remote sensing. Generally remote sensing is what? Remote is simply we can define is acquiring information about something without getting in contact with that. So here we are talking about, that is, acquisition of information through by the satellites, by the aircrafts, drones, or we can say etc., without getting in contact with the earth's feature. That is what we can say remote sensing. And nowadays remote sensing, the satellites play a very important role. It it acquires voluminous data through which we take the most usable information according to the set criteria. So it provides, basically we can say remote sensing provides information about the land cover, different types of land covers, that which is the built up area, which is the vegetative zone, which is the agriculture area, water body, etc. Through that remote sensing we can assess various types of phenomena also, like what is the vegetation health, or how what type of climatic pattern is existing in a particular place. And remote sensing not only it also includes various techniques for the image classification. For example, we can have different land cover categories through the classification. We can also have change detection and spectral analysis also through the remote sensing. So geographic information system and remote sensing, these are the very important tools of the spatial analysis. Another important tool I can quote here, that is the spatial statistic. You can see here the spatial statistic. So basically this tool analyzes the acquired data, that is the spatial data, in order to find out the relationship between the phenomena, between the certain objects or entities, or what type of patterns or relationship is existing in that particular spatial data. Through the techniques like you can see here, like spatial autocorrelation, spatial regression, and hotspots analysis. If you remember, I have talked about in previous lecture about the autocorrelation and hotspots analysis. Simply we can say clustering of certain activities, certain feature at a particular place, that is we can say hotspot analysis. Not only this, spatial statistics also help in understanding various type of spatial patterns, and it also helps to identify the cluster and accordingly to make the prediction. So this is also one of the very important tool. Another tool is global positioning system, GPS. It actually works on we can say utilizes the satellite signals in order to determine the precise location. Precise location means we are talking about in terms of latitude and longitude. So actually GPS determines the precise location of the objects on the Earth's surface, and it plays that much important role. By knowing the specified location of a particular place, we can get lots of information only by knowing the specific location. It helps in GPS helps in navigation, in asset tracking, in data collection in different disciplines, maybe in transportation, agriculture, natural resource management, etc. For example, we are using GPS. Through the GPS and there is application and softwares, we can in order to travel from one place to another, when you find out certain routes and all through the Google map, we have the use in that, you can say. Another important tool is network analysis. Whenever the term network comes, the first thing in mind comes, we are talking about certain road networks, transportation networks, or the connectivity, etc. So here also with the same meaning, actually the network analysis deals and it is one of the tool, we can say, which model analyzes the transportation, utility, and the communication network. They help in optimizing the route to find out the certain, we can say, route having the smallest distance route. We can find out through the routes without the obstacles. We can find out the fastest delivery route. We can find out. We can also find out, analyze different network connectivity, and even we can have we can assess the accessibility through the network analysis. And it is one of the very important tool in urban planning, not only urban planning but logistic, infrastructure management, etc. The another tool which I am going to discuss here is the Spatial Decision Support System, that is SDSS. This Spatial Decision Support System, this tool actually it is used to integrate the spatial data, whatever data we are having, with the decision making process. When we are going to integrate this spatial data with decision making process, we can have make lot of complex decision, we can complete lot of complex decisions tasks, like site selection for the particular facilities, amenity. We can also assess the resource allocation and the risk. We can also assess the risk assessment. Actually, this spatial decision support system, this provide the interactive interfaces in order to find out the spatial data, what type of spatial data we are having, what is the running scenario in that spatial data, and accordingly we can evaluate the certain alternatives. So these are basically, these are what these 6 tools I have discussed. This play a very crucial role in spatial analysis. Let us remember here, students. First one was GIS, that is Geographic Information System. Second one is remote sensing. That third one is spatial statistics. Fourth one is global positioning system. Fifth one is network analysis, and sixth one is SDSS, that is spatial decision support system. So basically this lecture is mainly based on the how the interpolation works in spatial analysis. Basically, what is interpolation? Simply in interpolation we find out the unsampled values of the unsampled location, means unknown values of certain places. For example, you can see here on the screen, you can see this is a certain site, we can see, and these are the sampled location, and we are having the values of only these 3 sampled location. In interpolation, what we do, we find out the values or attributes of unsampled, non-sampled locations and unknown values of the different locations with the help of the nearby known value, with the help of the nearby sampled location. For example, with the help of this we can find out the values surrounding it. With the help of this one we can find out again the values. With the help of this one we can again find out the values, so that we can find out the unknown values of the unsampled location in order to represent the spatial data in continuation. For example, if we would like to depict certain temperature data, rainfall data, that should be, or we can say while making the DEM, that is the elevation model, that is DEM, we can use the interpolation techniques. So basically it estimates the values within a set of known data points. So this was the known data points, this was the known data point, and we have found out, estimated the values within the set of known data points in order to, so these values can be represented in continuous manner. Interpolation basically fills in the missing or intermediate values in data sets. What I have made here, you can see we have filled the missing values, and it also enables accurate estimations at desired location, and we can use various type of interpolation methods which are existing according to the what type of data we are having and which type of method will suit better to a particular type of data. Interpolation methods can also be used to understand certain type of spatial relationships and trends also. Or here you can find there are different types of interpolation, what I have said, like IDW method, that is known as inverse distance weighing method, deterministic triangulated irregular network interpolation, that we can say TIN. Then we have Kriging method and spline interpolation. So there are different types of interpolation. So basically we are not concerned with the different types of interpolation. These are the interpolation which can be used while we are interpolating the values. Means this different types of interpolation is basically used on the basis of what type of data we are having, and accordingly we can choose the interpolation which suits in a best possible way. So the main part of the today's lecture, coming to the case studies here, student, you can see, if you see, this is the case study of KMC through IDW method, is inverse distance weighing method, which I have discussed in previous slide. Different parameters based air quality. Means you can see here carbon monoxide, oxides of nitrogen, particulate matter 2.5, PM10 and oxides of sulfur. So these are basically, and red points, here you can see red points in each of the map, you can find a student red point. These are the sampled location, these red points are the sampled location for the different parameters of the air quality. So basically we are having the values for these sampled locations and rest of the values to present the data in continuous form, so that the data follows a continuous pattern. We have interpolated in GIS environment. So interpolation has done. Now you can see this map, the data is presented in continuous manner. You can find the values of this according with the help of nearby sampled value. The data has been interpolated, and you can, for example, values for this, already interpolated values for this, already interpolated, the data has been represented in continuous manner. Similarly, you can see also for the oxides of nitrogen, particulate matter, PM 2.5 to 10, oxides of sulfur, similar pattern has been followed. Another example here, you can say representation of data through the interpolation of noise level. Again the red circles, these noise levels have been assessed from January to December. In each of the, you can find here 12 maps from January to December, this has been assessed. Daytime, and basically this is the assessment of daytime noise level. So these red solid circles are basically the sampled points where we know the value, the noise level of that location, we know the noise level. The monitoring is performed at this particular station. Sample sites are this. You can find these are the sample sites, and accordingly with this known value, the unknown values have been interpolated using the GIS environment. So in continuous pattern, this data can be represented, and through this representation we can get lots of information. For example, you can see June and July, you can find out how mostly the air quality is not very much good if we compare from the other months, June and July. So there may be some reason, accordingly we can June, July, August, accordingly we can find out the certain reason for that, why the noise level is high, particularly in June, July and August in daytime. Another assessment was made for the nighttime noise level. If you see again, same sampling site, same sample points we are having, and the known values were of same sample points, and accordingly we have interpolated in order to present a particular the data in continuous manner. So we can find out the trend. For example, if we are having this, for example, you can see the July map, students. If you are having this is showing the high level of noise level. Noise level is particularly high. So interpolation through this is there. Here we can find the decreasing point away from the particular site. We can find decreasing point. If we can say somewhere the noise level is low, for example in this portion noise level is low, we can again find out the another type of influence. So lots of information can be generated. So this is also basically a case study of Jodhpur city through inverse distance weighing method, where the different parameters based air quality have been analyzed and mapped through the interpolation using the interpolation technique. So basically you can see here the concentration of the first map A, that shows the concentration of PM10, B shows the A shows the normal day before Diwali about PM10. The first, this is the, we can say this blue one, this one, all the maps A, B, C, D, E of this is showing the we can say concentration of PM10. The red one is showing the concentration of PM2.5. Now A is the normal day before Diwali, B you can see here B1 this is the day before Diwali. Then C, this is the Diwali day. D, this is the day after Diwali, and E is the normal day after Diwali. So you can see the concentration of PM10 in different days before and after Diwali. The C is Diwali day and D is Diwali. You can find higher level of concentration. Similarly for the PM 2.5, again you can see on the map, students, 2.5 on the Diwali day, that is the C is the Diwali day, and day after Diwali you can see this is the day before the C is the Diwali day, D is the day after Diwali, and E is the normal day after Diwali. So in this map you can get the information. There is lots of PM 2.5 on Diwali day as compared to the before Diwali day. You can find out. Similar pattern was followed with the different parameters here. For the parameters like oxides of sulfur, the same pattern was followed and assessment was done. Is there any change in the oxides of sulfur in the atmosphere? Could be analyzed from day before to day and day after Diwali, and similar type of analysis was done for oxides of nitrogen, and similar type of analysis was performed for lead. You can see lead here, you can see lots of emission. Lead, you can see here lots of emission in this particular site, lots of emission. Similarly for the nickel, you can see the analysis have been performed, and for the aluminium and all you can see similar type of analysis is performed. So basically having this type of interpolation, we can get lot of information where the concentration is high, at which location is concentration is high, what is the cause of that high concentration, etc. Not only this, for various other elements this same analysis was done. So another case study, that is the case study of Willard Lake. You can see here the spatial variation and concentration of values of depth. This is the depth values, interpolation of depth values, interpolation of temperature, we can say Willard Lake, interpolation of pH values. Then we have here the turbidity values, then we have the calcium content, then we have the magnesium content. So interpolation of these parameters, basically this is a physico-chemical analysis of water. So interpretation of these parameters, again here I can say the sample site, you can see students, the red solid circles, this is, if you see here on the screen, this is the red solid circles, these are the sampling sites. If you see, these are the sampling sites. So basically we are having the 6 sample sites, and with the help of this sample, with the help of the values of this 6 sample sites, we are going to evaluate the unknown values of different space, you can say different spatial unit. So we are going to here evaluate the values for all these unknown values here. So accordingly we have different type of interpolation for the depth, temperature, pH value, turbidity, calcium and magnesium. This is again the spatial variation of concentration values of calcium hardness, magnesium hardness. You can see here calcium hardness, magnesium hardness, total hardness, conductivity, total solids and dissolved oxygen. So everything has been interpolated in order to present the continuous nature data. Where the level of particular parameter is high, we can get the information why it is high, accordingly we can assess. Where the parameter of this particular concentration is low and what is the particular reason for that. So everything information can be find out. For example, another, now again the spatial variation in the concentration of the values of alkalinity, free carbon dioxide, chloride, ammonical nitrogen, nitrite nitrogen, orthophosphorus, all these have been assessed and interpolated accordingly. So After assessing and having the interpolation of all the parameters which we have discussed in previous slide, we can also have the map of water quality map for this particular water body. Through the particular formula, using the particular formula of water quality index, we can find out the water quality index based on the parameters which we have assessed for these sites. Like these are the sites, for this we can calculate the water quality index. One water quality index is calculated for these sites, these sample sites. It can be further interpolated to get the water quality index. So how this is helping us, you can see here, at a glance we can get information where the water quality index is good, where it is poor, which are the zone which are which is facing a major deterioration in the water quality, which are those zone which is not that much vulnerable to deterioration, we can say. So at a glance we can give lots of information through the interpolation. So basically we use interpolation to know the values of unsampled points. Means we are going to evaluate the unknown values with the help of the known sampled points. That is what interpolation, and these are used in various fields. For example, what I have shown through the noise level, through the air quality, through the, we can say, different water parameters have been interpolated, and finally water quality index that has been also interpolated to give some information, and by getting those information we can have smart decision making process. So interpolation also help us, it facilitates in informed decision making process. So we will discuss another tool in the next lecture. So till that, have a good day. Thank you. Thank you, students.